Hello and welcome. In this tutorial, we are going to talk about eigenvalues of a 3 by 3 matrix. And as you're seeing on your screen, we have a matrix there, and we have been asked to find the eigenvalues of the matrix. So we are still going to obey this law here that says that the matrix, when we subtract the eigenvalue multiplied by the identity and find the determinant, we should get a 0. So that is the rule you are going to obey there. And you are going to, as we are seeing that the matrix there we are having, it is 1, 2, -1, and we are subtracting lambda, which is the eigenvalue that we want to find, multiplied by the identity matrix. This one should be giving us a 0. Yes, and from that point we can see that we are going to have that is what we are going to be having from that point, and we are going to find the difference, and by finding the difference we'll be having now this value. You are going to subtract this one, and at this point you are going to subtract this one, and at this point you are going to subtract this one, meaning that only the values at the diagonal are going to be affected. So we'll be having 1 minus lambda 1 4, then 2, then we're going to have minus lambda, because 0 minus lambda is negative lambda, -4, then -1 1 5 minus lambda, and this one should be giving us me a 0. So we are going to obtain the determinant, and let me just use this point here. So the determinant of this matrix will be given by, now we are not going to use this one, so we'll be taking row 1 here, that is 1, then we take the minor matrix, meaning that we are not going to pick the values in row 1 and in column 1. So we'll be having negative lambda, -4, 5 minus lambda, then minus 2, and this one we are going to pick the minor matrix, so it is 1 4 1 5, then again we are going to subtract 1, and this one we are going to pick the minor matrix, there will be 1 negative lambda 4 -4, and this one will be giving us 1 minus lambda into, this one is negative 5 lambda plus lambda, then again this one is -1, and -4 times 1 is -4, so it will be +4. Then we'll be having 2 into 5 minus lambda minus 4 minus 1 into -4 minus, so it is +4 lambda. This one should be equals to 0, and this one we are seeing that we'll be having 1 minus lambda into -5. So this is, I'm sorry, here we were having negative lambda times negative lambda, that was to give us positive lambda squared. So we'll be having -5 lambda plus lambda squared plus 4 minus 2 into 1 minus lambda minus 1 So we can just factor out these 4, and we can just factor out a negative also. So we'll be having positive sign here because we'll now factor out a negative. So positive 4 into, so this one will now become a positive 1 minus lambda. Yes, this one should be giving us 0. So as we can see that this value here is common in every point. So we can just factor it out. So we have 1 minus lambda, and this one is into lambda squared minus 5 lambda plus 4. Because we have factored here, it was twice, so we are going to subtract 2, and again we are going to add 4. And this one will be now 1 minus lambda into, now this equation here will be now lambda squared minus 5 lambda, and this is minus 2 plus 4 is 2. This one will be plus 6. So we need to find the values that when we add we get negative 5, and when we multiply we have a positive 6. So those factors are negative 2 and negative 3. So we'll be having lambda minus 3 and lambda minus 2. So those are the factors that are going to get from this equation. So for us to solve for the eigenvalues, you're going to equate everything here to 0. So when you equate this value here to 0, you're going to get that lambda 1 is 1, lambda 2, when you equate this one to 0, we'll be getting 3, and lambda 3, you're going to get 2. So that is how we are finding the eigenvalues of a 3 by 3 matrix. Thank you for watching.